Let's look at what we talked about in the past. We first talked about natural numbers. What are natural numbers? See, I'm saying between your classes, don't sit in the hallways looking at your phones. So look at your notes, review your notes, because I might start having quizzes at the beginning of each class period, and each quiz can be over anything we've covered to that day, because you guys obviously are not reviewing your notes. These questions I'm asking you are basic. We've been talking about them for 8 weeks now. Because I know you're going through your head. Oh, with deadlines not due, I could use my notes on the test. I can do this. I'm going to start making it more difficult for you, because you guys aren't doing your part of the deal. What's a natural number? Put your phones away. If you have your cell phones out, put them away. If I see another phone out during class, I'm going to start giving quizzes, because you guys are getting way too lax with this stuff. I appreciate you guys are here. Trust me, I really appreciate you guys are here. But if you're here, pay attention. If you want to be on your phone, stay outside. Watch the video. Either take this class seriously or fail. What's a natural number? What's a whole number? You should have been doing your homework too. What's an integer? What's a rational number? An irrational number. These are all the words we covered in class since day one. Well, I should say I covered in class. You guys were probably on your phones. Not all of y'all. You see why I'm kind of upset right now. We covered this stuff. Every class period, I always talk about these. They're counting numbers. 1 to infinity. 1, 2, 3, 4, 5. Those are the natural numbers. Whole numbers. Whole numbers are natural numbers, but they begin with 0. Integers go from negative infinity to 0, and then to positive infinity. Those are all the numbers, positive, negative, and 0. Rational numbers, fractions. Irrationals are also fractions, but there's a difference. The decimals are either finite or repeating. They either end or they keep on repeating, like 25, 25, 25, 25, or 0.33333333. An irrational number is a fraction that is infinite and non-repeating. Rational numbers are all those above there. All of these make up the rational numbers. All of this stuff, all of these constitute rational numbers. I mean, are real numbers, real numbers. Rational numbers are fractions that either have a finite decimal point or they're repeating. They end, they terminate. Like 1/4 is 0.25. It's done, it's finite, it has 2 decimal places. Or it could be infinite, like 1/3 is 0.3333333333. Goes on infinitely. So that's either finite or it's repeating. You can tell me what the next series of numbers are. So that's what these are. This is chapter 11, sections 3 and sections 4. Adding and subtracting real numbers. How would you add decimals together? When you add and subtract decimals, line up the decimals. And anything that's missing up and down, you put a 0 in that place. But you line up the decimals because the answer is going to have the decimal right there. 0 plus 4 is 4. 3 plus 0 is 3. 8 plus 5 is 13. When you're adding numbers with different signs, what's the rule there? Line up the decimals, then what? Very good. If the signs are different, you line up the decimals and subtract them. So put the bigger number on top, minus 517. 6 minus 7, you can't take away 7 from 6, so we have to borrow 1. That becomes 6 becomes 16. 16 minus 7 is 9. 7 minus 1 is 6. 9 minus 5 is 4. So there you have it. It's positive. We know the answer is positive because 9 is bigger than 5. 2/3 plus 4.5. They're both real numbers. How would you add them? Or turn the decimal to a fraction. That's safer. It's much safer to convert decimals into fractions because they're going to be one set of numbers. This number here, 2/3, is 0.666666666 infinitely. So you can't, it's not going to be safe to do that. So how do we convert 4.5 to a fraction? Mm-mm. It has to do with moving decimals, yes. Right now, what number is below there? 1. Every time I move a decimal, what am I doing? When you move a decimal, you're multiplying by 10. Each decimal spot is a 10. So if I move it one decimal place, I multiply the top by 10. If I multiply the top by 10, I got to do the bottom also. So I got 45/10 is the same thing as 4.5/1. Now you can add them however method you want. 10 times 2 is 20. 3 times 45 is 135. And multiply the bottom. $45 times 3. 3 times 5 is 15. 3 times 4 is 12 plus 1 is 135.
Wait, can you explain the part where you move the decimal and knowing how you're supposed to multiply by 10?
Well, yeah, the rule is this. Bless you. Each decimal space is a factor of 10. Yes, it's a factor of 10. If I move the decimal to the right, each space is a 10 multiplied by 10. If I move the decimal to the left, each space is 1/10. Because when you divide by 10, you're making the number smaller, so the decimal goes to the left. If you multiply by 10, the number gets bigger, decimal goes to the right. So did you ever wonder why 3 times 10 is 30? Because 3 is actually 3.0. I'm multiplying by 10, which means I'm moving it over one space. It becomes 30.0. Since it's a 0.0, I can get rid of it. That's how it's supposed to work. That's how you're supposed to have been taught back in elementary school and junior high. But we got so complacent that 3 times 10 is 30. Okay, great. But what it really means is you're moving a decimal one to the left. Not one to the right, I mean. All right. So what does this we get so far? 20 plus 135 is 155 over 30. Oh, 155. Yeah, I was hoping for 150 is much easier. 155. All right, let's see this. It's an improper fraction. But before we do anything with improper fractions, it's a lot easier if we simplify. Or you can divide if you want to. Whatever you want to do, you can do whatever's easiest for you. In other words, our number 155 over 30, we could do it one of two ways. One way is we could just do straight up division. How many times does 30 go into 155? Yeah, 30, 60, 90, 120, 150. 5. 3 times 5 is 15. So 3 times 0 is 0. 3 times 5 is 15. Subtract them. So your answer is 5. That whatever here's on top is your integer. This number is your remainder. This is your denominator. Can we simplify here? Yeah, 5 goes into 5 once. How many times does 5 go into 30? 6. So there's your answer. If the question asks for a decimal answer, all you would have to do is find the decimal of 1 over 6 and just put 5 point whatever the answer is. Let's see how we would do that. Let's make this into a decimal. Okay, so we have 1 divided by 6. So 6 goes into 1. Does 6 go into 1? No, so I put a decimal there, which puts a 0 behind it. Does 6 go into 10? 1 time. 1 times 6 is 6. Subtract those, I get 4. It's actually 40 because I'm now in the next decimal spot. How many times does 6 go into 40? 6. 6 times 6 is 36. Subtract those, I get 4. Because I'm moving to the next spot, I put a 0. You see what's going to happen from here on out? Because it's always going to be 40. It's going to be 6, 6, 6, 6, 6. Yep. So the decimal equivalent would be 5.16 forever. That bar on top means that number 6 repeats forever. Okay, that's one way of doing it. The other way we could have done it is by factoring first. So what makes up 155? What numbers go into 155? Look at the last digit. What number fits into 5? 5. 5 goes into 15 3 times. 5 goes into 5 once. 31 is a prime number. So it's made up of 5 times 31. What's 30 made up of? 3 times 10. 10 is made up of, so it's 2 times 3 times 5. Can anything cancel? The 5s. So we got 31 over 6. How many times does 6 go into 31? Yes, 5. So 6 goes into 31 5 times. 5 times 6 is 30. So it's 5, 1 over 6. The bottom number has to stay the bottom number. You know, it's the same answer. It's got to be the same answer. But you can do whatever method you want to, you can do it. You can simplify first and then divide, or divide first, then simplify. It's going to give you the same answers. Any questions?
When it's not mixed number like that, you just to get the decimal, you just divide
The decimal point. Yes, I'm glad you asked that. Yes, very good question. If you have a mixed number, that's the same as splitting those two up. So let's say we had 2 4/5. That's the same as writing 2 plus 4 over 5. Well, what is 4 over 5? Does 5 go into 4? No, so I put a decimal. Does 5 go into 40? How many times? 8. 8 times 5 is 40. So this becomes 2 plus 0.8. Well, if you think about it, 2.0 plus 0.8 is 2.8, which is what we're going to do. Just add the two numbers together. Treat them both separately. That's very, yes, that's a very good question, because in mixed numbers, the fraction and the coefficient.
the big number on the side is just the.
It's the number in front of the decimal. It's gonna be the number in front of it. Yes. Excellent question, actually. Yes, thank you for asking that. Add these two together. If you can do it in your head, go ahead and do it in your head. You know what it is? 1 over 2 is what? Half, 0.5. So this is 4 plus 0.5, which is 4.5. Okay, let's put some look at the end of the section homework problems. Adding real numbers. Let's go this way. We're also going to start talking about word problems again. Let's look at these. Let's start with number 15. This is chapter 11, section, what section I pick? 4, I believe. Section 4. Question 15. -10 plus -3. Using the order of operations, what do you do first? Can we do anything inside the parenthesis? So no. If you can't do anything inside the parenthesis, that parenthesis must disappear. We have to get rid of it. How do we get rid of it? Yeah. What number's in front of a parenthesis if there's nothing there? Very good. There's a 1. So we have positive times negative is what? Negative. 1 times 3? 3. I know it's not the way you were taught, but try to get used to working the signs and the numbers separately. It'll always make it easier that way for you. Now, since the signs are both the same, what do? Yeah, we take the common sign, they're both negative, and we add the numbers. And there's your answer. These procedures are in your notes somewhere. Twice. Okay. Which one do you do next?
19.
Okay, 19 looks like a good one. Question 19. 10 plus bracket -3 plus -2. Now you see another reason here why I don't like PEMDAS. Because you can't use PEMDAS here. Because there's no P for parentheses or B for bracket anywhere. All it says is parentheses, exponents. Where's bracket come in? Bracket and parentheses are the same level of importance. So any special operations we do inside here first. Yeah, we have to do what's inside the brackets first. So inside the brackets, we follow the same order of operations. We can't do anything inside the parentheses, so we have to get rid of the parentheses. There's a 1 there. So positive times negative. 1 times 2. So anytime you have what's called a nested operation, this is one equation, an operation inside another. So inside the brackets, we have to follow the same rules of operations. Repeat the process. Here's a special operation. Can we do anything inside there? -3 minus 2. What's the rule there? Well, first off, since they have common signs, what do? Take the common sign and then add them. 3 plus 2 is. Yeah, so remember, treat the signs and the numbers separately. If the signs are the same, use the same sign and then add the numbers. Repeat the process. Here's a bracket. We can't do anything inside there, so we have to get rid of it. There's a 1 in front of it. Positive times negative. Negative. 1 times 5. The signs are different. What do? But what about the sign? Take the sign of the larger number. The answer is going to be positive, and subtract. 10 minus 5 is 5. Because again, it's the signs that are going to ruin your grades. The negatives are going to pop up or disappear when you don't want it to. So be very, 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 very careful about that. All right, let's look at them. Let's pick another more difficult one. Which one you want to do? 20? Let's do both 26 and 25. Since I heard both of those numbers in my head. 25 is -8 plus bracket 3 plus -1 plus -2, and then 26 -7 plus 5 plus -8 plus 3 there. Hold my page. There, here's your mark. I'll let y'all do these first. Let me pause this. Okay, looking at this process, we have to do inside the bracket. Inside the bracket, do the parentheses. We can't do anything there, so we have to get rid of it. There's a 1 in front of it. Positive times negative is a negative. 1 times 1 is a 1. Repeat the process. Here's a bracket. Here's a parenthesis. We can't do anything, so we have to get rid of it. Positive times negative is a negative. 1 times 2 is 2. Three minus 1 minus 2 is 0, because -3 plus 3 is 0. So that's gone. So the answer is -8. Same thing on this side. We have to get rid of the parentheses. Positive times negative is negative. 1 times 8. By commutativity, there's the property we're going to talk about in a little bit. I can move these numbers around. 5 plus 3 is 8. 8 minus 8 is 0. There's your answer. Yeah, how many of y'all thought the question looked hard before you started? But yeah, once you break it down, I was surprised too. Ooh, yes. Got it? Ooh, now we have fractions and decimals, so bigger equations. Let's do 27 and 31. (27) is 9/10 plus -3/5. Okay, let's look at the first one. We can't do anything inside the parentheses, so we have to get rid of it. 9/10. Positive times negative. Negative. 1 times 3/5 is 3/5. Okay, yes, you could do it one of two ways. Because you see the denominators are pretty close, we could just go ahead and try to get common denominators. Let's do it both ways. 9/10 minus 3/5. 9/10 minus 3/5. So since the common denominator is what? 10. So to get 5 times what is 10? So we have 9/10. 3 times 2 is 6. 5 times 2 is 10. If those are the bottoms are the same, you just worry about the top now. The answer is 3/10. Or you could have used the butterfly method. Ten times 3 is 30. 9 times 5 is 45. There's a minus sign between there. 10 times 5 is 50. So we have 45 minus 30/50. 45 minus 30. What is 15 made up of? 3 times 5. 50 is made up of 5 times 10. The 5's cancel. So we're left with 3/10. Yay! Yes, because the denominators are so close together. But if this was like a 21, this is like a 36. It's easier. It's just pick your poison. It's see which one you call. It's easier for you to do, but you'll get the same answer both ways. That's the only thing I'm worried about. Some teachers say, "Well, I can't give you credit because you didn't use the method I wanted you to use." That's stupid. What's that? This one is, it should be 0.3 or 10/3. This is number 27. That's question number 27. Yes. Butterfly method, yes. The butterfly method is only for addition and subtraction. If you're multiplying and dividing fractions, what do you have to do? Reduce first, factor them, reduce first, cancel anything top and bottom, and then multiply. Then you're done.
You can do it the same as this common denominators, and then just use the
Not when you're multiplying. You don't need to common denominator when you multiply. We'll get to it, but that's the third section. We're going to cover addition, subtraction, and then multiplication, division. We've done it before with whole numbers. Now we're doing it with real numbers. Okay. 2 ways you can do this. Actually, there are 3 ways. There are, again, it's just, there's no real wrong way to start, as long as you follow one of the rules we discussed. One rule. Well, you probably converted decimals first. Yeah. So what is 1/2 in decimals? That's 2.5. What is 1/4 in decimals? 0.25. It's like 1/4 of a dollar is 25 cents. Different signs makes it a subtraction. Different signs. So what sign do we take? What number is bigger? 3.25. So the answer is going to be negative. Now we take the 2 numbers, 3.25, and subtract 2.5 from it. 5 minus 0 is 5. You can't do 2 minus 5, so you got to borrow 1. 12 minus 5 is 7. And here's a decimal. Yes, but there's a problem with that. It's not wrong. The common convention of mathematics says this: if you start off with fractions, you have to end with fractions. So what you have to do here is convert that. How would you convert 0.75 into fractions? Well, it would be, yes, but how do we get there? Yeah, you're right. How do we get there though? What's that? Yeah, so we know the answer is going to be negative, so don't worry about that. How many places do we move it? 1, 2. So you move it 2 decimal places, so it's 75. And so I have to have 2 zeros on the bottom. Since I moved it 2 decimal places, I need two zeros on the bottom. Bless you. Now we can simplify. 25 goes into both of those. 25 goes into 75 3 times. 25 goes into 100 4 times. So negative 3/4. Another way you can do it. No. It all depends on how many decimal places. If you only have to move it 1 decimal place, if it was 0.7, then it'd be 7/10. It just depends. That's how many zeros are on the bottom. Yes. Another way you can do it, you could have converted these mixed numbers into improper fractions and then subtract them. How do you convert 2 1/2 to improper fraction? Here's the formula. The coefficient times the denominator plus the numerator. Oops, I'm sorry. There's the formula. Whatever's out in front times the bottom plus the top over the bottom. So the first one, 2 times 2 is 4 plus 1 is 5 over 2. Positive times negative is a negative. 3 times 4 is 12 plus 1 is 13 over 4. Again, here we can either do the common denominator or because they're easy denominators, or we can do the butterfly. Since 4 is the smallest number, we have to multiply 2 and 2 here. 10 over 4 minus 13 over 4. Since we have a common denominator, we just worry about the top.
Can I see the top part of the second?
And this is also a reason why the negatives always go on top instead of the bottom, because when you subtract them, it's always subtract the top numbers only. What do you see?
Wait, how did you do this, the second part?
The second one?
Yes.
Well, first off, since I had 2 signs here, positive times negative is a negative. I got rid of the sign. I don't have to worry about that anymore. According to this rule, whatever's in front times the bottom plus the top. 3 times 4 is 12 plus 1 is 13 over the bottom 4. You see why math is inductive. We have to use what we learned 2 or 3 chapters ago. We learned how to convert mixed numbers to improper fractions and improper fractions to mixed numbers. There was a reason for that. Here we go. This is the reason. So everything we learn now, we're going to use sometime further on down the road. Everybody okay with this so far? Okay, we have to keep on moving. You almost finished? Oh. Yes. Oh. Let's look at number 51. This one's asking us, determine whether it's true or false. -7 plus bracket -5 plus -3 equals bracket -7 plus -5 plus 3. Let's treat both separately. So in the first one, we have to do the left side, the bracket. We can't do anything with parentheses, so we have to get rid of it. Positive times negative is a negative. 1 times 3 is 3. -5 minus 3. They're both negative, so 5 plus 3 is 8. If the signs are the same, you add them. They're both going the same direction. We have to get rid of it. We can't do anything inside the bracket, so we have to get rid of it. Positive times negative is negative. 1 times 8 is 8. They're both negative, so the answer is negative. 7 plus 8 is 15. Very good. Same logic on the other side. You have to do inside the bracket first. Can't do anything inside the first one, so since there's nothing, we just drop the parenthesis. Same thing with the second parenthesis. Positive times negative is a negative. 1 times 5 is 5. They're both negative, so the answer is negative. 7 plus 5 is 12. There's nothing in front, so I can just drop the parentheses, or the brackets, I should say. Different signs. 12 is bigger, so the answer is negative. And subtract them. 12 minus 3 is 9. Not equal, so it's false. As I said, worst case scenario, you got 50-50 chance. All right. Now the pieces of math you've been waiting for this entire semester. Word problems. Let's look at 53. The sum of -5 and 12 and 6. Well, we'll also look at 55 while we're here on this page. 14 added to the sum of -19 and -4. Okie doke. When we read this thing, the first math word we get to is what? Sum. What does sum mean? It means addition, means plus. So it's addition of this number and this number and this one. So it's -5 plus 12 plus 6. -5 plus 12 is a positive or negative? Positive. 12 minus 5 is 7. Positive 7. 7 plus 6 is 13. Yay! All right, the next one. A little bit different. It says 14 is added to. What does added to mean? Plus to the sum, which is plus also, of these two numbers. So we use parentheses. So we have to do -19 plus -4. Brackets. And then 14 is added to that. So here's the sum of those two numbers, and then 14 is added to that. Positive and negative is a negative. -19 minus 4 is -23. There's nothing in front of the brackets, so I can just drop them. And the answer is 78. Ah, you caught me. I was gonna see if anybody was listening. You guys are just bobbleheading. Is the answer gonna be positive or negative? Negative. Negative what? 9. Yes. Yes. You guys are just writing away. I see you're just gonna write it down, keep on going. Actually, what I would like to, well, it's 42. I want to save the word problems for after the break. Let's just go ahead and do the mechanical parts right now. Addition, subtraction, multiplication, division. We just talked about addition, but it's the same concept with subtraction. So that was section 11.3. Where's that? Section, no, 11.5 is subtraction. And there's no real new thing added there. 16 and 17, or 16 is multiplication division. Let's look at that.
What section is this?
We'll just finish with sections 4 and 5. This is section 6. The 4 deals with addition, 5 deals with subtraction, 6 deals with multiplication division. Oh, that's what I need. Oh, I'm sorry, you're gonna see that. You did. All right. Really quick. Chapter 11. Why is it not switching over? Chapter 11, section 6. The multiplication and division of real numbers. Actually, we talked about these last time. When we talk about real numbers, we talk about the integers, the rationals, and then decimals. There's not much else. Can you multiply, divide integers? Like 8 divided by 16 or negative 8 over 16. What is that going to be? Yeah, it's going to be negative since there's one negative. 8 goes into 8 once. So it's negative 1 over 2. So we know how to divide. How about multiplication? Do we know how to multiply? Without a calculator. So 16, we know the answer is going to be negative, so there's only one negative. 16 times 8. 6 times 8 is what? 6 times 5 is what? Or 8 times 5 is what? Is 40. Plus 8 makes it 6 times 8 is 48. 8 times 1 is 8. Plus 4 is 12. So that's, we also know how to multiply. It'll take you some time. Use your fingers if you have to, but that's multiplication division. We know how to do that already. So integers is no problem. We've been doing that all along. Two over 3 times 9 over 24. What's the rule for multiplying fractions? Reduce first. Yes. If it's easier for you, if your multiplication skills aren't that strong just yet, you can just go ahead and factor these things out. What is 9 made up of? 3 times 3. How about 24? What is 24 made up of? 6 times 4, you can do that 4 or 4 times 6. 4 is made up of. 6 is made up of. So it's 2 times 2 times 2 times 3. All these. Remember, 24 ends in a 4, so we know it's divisible by 2. 2 times 12 is also 24. Didn't I give you those divisibility sheets a couple weeks ago? The rules of divisibility of from 1 through 13. I thought I did. I thought I did. Check your notes. If not, then I'll give them to you. I'll send them up to y'all. Because yeah, it's a step-by-step. It's a divisibility rule. It's about 2 weeks ago. It's a sheet I gave y'all. Okay, I'll send it to y'all. So now that you factored everything out, anything on top can cancel with anything on the bottom. The 3 cancels with this 3. This 3. This 2 cancels with that 2. So these 2's cancel. These 3's cancel. These 3's cancel. What are we left with? 1 over 4. Because we have 2 times 2 on the bottom. And there you have it. So our answer here is 1 over 4. You can multiply across and then can simplify, but that's think about it. 3 times 24 is going to be 72. Top is going to be 18. 18 is over 7. You're still eventually going to have to break them down to its smallest pieces. It's much easier if you do it right off the bat. How about if I had this? 2 over 3 divided by 24 over 18.
Don't you have to simplify 24 and 18?
Very good. We should have done that here. Before you do anything, if you have fractions, always simplify first. We could have simplified this one equation here first. It would make it much easier for us. Yes, good catch. Always simplify. So look, we have 2/3 divided by, what can these simplify into? 24 is made up of 4 times 6, 2 times 2, 2 times 3. And 18 is made up of 3 times 6, or 2 times 9. 6 is made up of 2 times 3. Right? So 24/18 is 2 times 2 times 2 times 3 over 2 times 3. The 2's cancel, the 3's cancel, so we're left with 4/1. So this one simplifies into 4/1. Yes, I'm glad you caught that. Whenever you have fractions, simplify first before you do anything else. Okay, now the rule is take the first fraction, leave it alone. Change the division to multiplication and flip the second one. So change from division to multiplication and flip the second one. And can anything on top and bottom cancel? The 2 goes into 2 once, 2 goes into 4 twice. So we have 1, 3 times 2, 1/6. The answer is 1/6. Makes sense. So that's in multiplication division, the only problem we have here is we have division over division, flip them, because this is the same thing as this. So leave the first or the top one, leave it alone, change it to multiplication, and then flip the second one and multiply. So that's the only thing that's different there. The only thing that's different really now is we have to include decimals, and we've learned already how to get rid of decimals. You think you remember this stuff? Okay. Clear your desks. No cheating. Clear your desks. I tried to last minute memory. Okay. No. Go start your vacation. I'll see you guys in 12 days. Okay, that was an easy quiz. Y'all passed. Yeah. Well, you had to clear your desks to get out of here. Y'all be safe and have a fun time. I'll see y'all in a couple of weeks. Come on in. You too. Thank you. You too.
I am more than ready for spring break. Yourself?
Oh, hello, yeah.
Well, it was, what's the worst thing about it is I thought I was gonna have an enjoyable one, but because of we were renovating our kitchen. And the contractor that we hired lied, cheat, and steal from us, $20,000. Yes.
Wow.
So needless to say, it's now past small claims court. It's going straight to district court. Oh, yeah, I mean, and while they were there, they only worked 4 hours a day at most. The down payment we made for our work, the foreman used that money to pay his own bills. And when he tried to go pay for anything for our project, his credit card was denied every time. So where did all that money go to? And so that's why it's not gonna get really. His wife and my wife work at the same school. And she was the one who suggested, "Hey, my husband is a contractor, we hire him." That's well, we're wondering, does she even know what he's doing? Because we had $20,000. Does she know where that money? Does she even know that? So, I'm sorry. It's that my mind is.
Yeah, I've had that contract. That's like
So, there goes my faith in man.
That's what it does, good, doesn't it? That one experience is all.
Yeah, it does. And it's good. Zeros behind it.
Uh-huh.
Y'all have a fun thing. Pretty dangerous.